Hello everyone. My AAT topic for AAT concept video is principles and types of aerial photogrammetry of remote sensing and GIS uh, GIS course. And my name is N Rishabh and my roll number is 24955A0115. So let's start the AAT. Introduction. Aerial photography captures images from airborne platforms, offering critical insights across many fields. Understanding its principle and types aids in selecting appropriate methods for application like mapping, environmental monitoring, and planning. This presentation outlines fundamental concepts and categorizes main aerial photograph types for professional use. Principle of aerial photography. Fundamentals of aerial photography. Aerial imaging involves capturing photos from aircraft or drone at varying altitudes. Key principles includes perspective geometry, scale, and the relation between camera, aircraft, and terrain. High precision in capturing these elements ensure accurate mapping and analysis. Camera and sensor types. Different cameras and sensors produce diverse aerial photo image qualities. Optional ranges from traditional film cameras to modern digital systems with multispectral or infrared capacities. Choosing the right sensors depends on the resolution needs and specific application goals. If the resolution of the camera is high, we will get a very high quality photo, and it's vice versa. If the resolution is low, we will get a low quality photo. So resolution of camera matters. For better resolution, we should select the multispectral or infrared capability cameras. Flight planning, and geometry. Effective aerial photography requires detailed flight planning, including altitude, flight path, and overlap between images. Understanding geometric factors such as tilt, lens distortion, and relief displacement com- optimizes the image accuracy and coverages. Optimizes image accuracy and coverage. So now let's see about the types of aerial photographies. Vertical aerial photographs. Aerial photos are taken with the camera lenses pointed directly downward. They provide accurate scale and minimal distortion, ideal for mapping, surveying, and other creating orthophotos for GIS integration. In this GIS means Geographic Information System. So aerial photographs are mainly used for surveying purposes, and for preparing maps, and for GIS integration purposes. So next type is oblique aerial photographs. Oblique photographs are captured at an angle, offering more contextual landscape views. They include high oblique and low oblique photos, usually for interpretation, reconnaissance, and urban planning due to the perspective richness. So it's a main difference with vertical photographies. It is in a perspective way. So it is mainly used for visual interpretation, resonances, and urban planning. So there are two types of oblique photographs: high and low oblique. In that high oblique photograph, we will have more distance and with more resolution, and in low oblique photograph we will have a low tilt among the vertical photograph, low tilt between, and we will have less horizon. Low and high attitude photograph. Low attitude photograph offers high resolution images ideal for detailed surveys and inceptions. High altitude photo covers larger areas suitable for board mapping and monitoring. Selecting the appropriate altitude balances image clarity and coverages depending on the project scale and purposes. So the low photographs offers high resolutions, and high altitude photographs offers low resolutions. Technical considerations: scale and resolutions. Scale determines the ratio between image size and real world size, affecting detail clarity, whereas resolution reflects the small object that can be distinguished. Both factors are crucial for accurate measurement and effective analysis in aerial imagery applications. Image distortion and correction. Distortion arises from camera lenses, terrain relief, and tilt angles. Correcting these errors using photogrammetric techniques ensures geometric accuracy. This process is essential for producing reliable maps and spatial data from aerial photographs. So, we need to identify the distortions occurred in the aerial photographies between the images, and we need to apply the correction for the distortion occurred between due to the reasons like camera lenses, terrain relief, and tilt angles. Lightning and weather effects. Lightning conditions and weather significantly impact image quality. Optimal photography requires clear skies and consistent illumination. Shadows, haze, and atmospheric conditions must be managed to maintain image clarity and usability. Applications of aerial photography. Cartography and mapping. Aerial photography provides precise spatial data critical for creating up to date maps. It supports topographic mapping, land use analysis, and geographic information system projects (GIS projects), enhancing the accuracy and details of cartographic outputs. Environmental monitoring. These methods enables the tracking of environmental changes such as deforestation, erosion, and urban expansion. It supports a sustainable development by providing timely, high resolution data to access ecosystem health and human impact. Urban and regional planning. Aerial images assist planners in evaluating land use, infrastructure, and growth patterns. They offer visual insights that improve decision making for zoning, transportation, and development projects, ensuring the efficient and sustainable urban management. Conclusion. Aerial photography is a powerful tool combining the precise principle and diversion photography types to achieve the detailed spatial analysis. Mastery of technical considerations enhances image accuracy, supporting varied applications from mapping to environmental and urban planning. Understanding these fundamentals is crucial for professional employing aerial imagery in strategy decision making. So this is about the aerial photography. So we can use aerial photography as an effective method for the following types like surveying, or for obtaining the maps and details urban plannings etc. Thank you.